Posted a test, and I'm not here Thursday. Please don't come to class because there will be none, and I won't be here. So there's no class. So in the assignment section, test 1. Oh, it might help if I turn the freaking projector on. Too bad. So, I have test 1 posted. It's due Tuesday, week from tonight. Okay, I need your 3 router configs. Let's pull this up real quick. Yeah. So, again, 10 questions. This should say 3 routers, my fault. All 3 routers. Typo. Apologize for that. Alright, configure each router with proper modules. You're going to have to add a module to R2 because if you just use a standard 3745, you only have 2 Ethernet ports. You need 3 Ethernet ports on it. IP addressing, routing. For this exam, you'll notice that there's no routing domains on the topology. No EIGRP, no OSPF. Now, that doesn't say that you can't use a routing protocol. Okay? I'm kind of leaving that up to you. If you want to use a routing protocol, if you want to make everything static routes, I'm leaving the networking piece up to you.
Does that give us points if we mess up somewhere else?
No. It makes you lose points because if I can't test your ACL, that's bad. Right? If I can't test your NAT on R2 because from R1 I can't reach your network, that's bad. Alright? This is still a telecom class. Believe it or not. Okay. Back to number 2. Give each router its proper host name. R1, R2, R3 respectively. Lock out the ACP engine on all routers. Disable CDP on routers globally. It should say all routers, not both routers. Statically NAT the DMZ servers to associate their global and private addresses in R2. Hint, your servers have a physical address on 172.16.0.0 NAT the server, so they are seen by their public IP from R1 and the internet, and also by their public IP from their interior network. Set up a port address translation for the 10.0.0.0/24 network so it overloads 14.40.28.38, which is here. Here. So that's where your path's going to go. Make sure you get it in the right spot. Set up a DHCP pool on R3 to support the 10 network. For the diagram, set your DNS server to the public IPs of the DNS server on the DMZ. Your internal IP .1 should be your gateway. Set your DHCP least to 5 days. For the DMZ, configure access lists for the following policies. There's all your security policies. Set up logging for all routers to be pushed to your ACS server on the DMZ. So make sure you have logging on all your routers. Make sure your facilities are set correctly. Set up the users. Set up a warning banner. Disable your aux port. Set the following usernames and passwords. utilizing strongest encryption for the passwords as possible. Make sure that you have encryption on your configuration. That's intent. I put that one in there for you, Steve.
I know you did.
And finally, create loopback interfaces on R1, R2, and R3 where their IP addresses are 1.1.1.1, 2.2.2.2, and 3.3.3 respectively. You may have to do a little Google search on how to set up a loopback interface. Okay? Hey, I have to separate the A students from the B students. Okay? Not hard. It's just you don't see a loopback interface in a default configuration. You've got to create it, and it will be in the config. Questions? If you have a question, you can always email me. I'm doing nothing but work this weekend, so I have plenty of time.
I got a generic question. Is it indicative of what the tests are normally like when you take them in class with a 2-hour window?
It's a little bit harder,
Okay.
but not much. I think I added R3, if you couldn't tell, the take home.
Okay.
Typically it was only going to be 2 routers for a 2-hour test.
I think we should have all take-home tests this week.
All take home tests? No, I gotta push the envelope, man.
I don't think so.
I do.
It's supposed to be easy for you.
An easy quarter?
Yeah.
You took me. That's wrong. What else are you in? Basket weaving 101?
Tom 411.
Tom 411. Okay, Tom 411 is not an easy class, I heard.
It's not.
No, it's a hard class. So you're taking the worst quarter I ever heard was a CIS major who took this class, senior project, Tom 411, and the finance class, the main finance class, the 400 level finance class, all in the same freaking quarter. Yeah, I'm like, really? I've left everything to the end. I'm like, well, I guess you were wanting a challenge. He was one of the few students I ever gave a C to in this class. Yeah. A's and B's. Depends on how you pull this stuff off. Okay? Depends on how you pull this stuff off. Usually, you'll know that the final is 200 points, and it's in class. You have 2 hours to configure a router, a firewall, and I'm kind. I don't make you set up a VPN. I did that one quarter. I think I had a couple students that almost came to tears.
You're so kind. That should be a take-home also.
No, I don't make that one a take home. I make you work for that one. The hardest one, the most heartbreaking one I ever had, one of my best students I ever had, Jeff Inbest.
You told me about that.
Yeah. He took the final and didn't save his configs. And he got a 0 on his final.
You're ruthless.
Dude, he ended up getting a B in the class. He ended up getting a low B in the class, but he ended up getting a B in the class. Yes, no mercy, none. All right, let's talk about about ACS a little bit more in depth. So, ACS comes in a few different flavors, not just Cisco. Okay, you can have open source solutions like a Radius server. You can set up a Radius server on a Linux platform, and it can be an access control system. All right, there's software that is in Microsoft Windows. And then there are appliance-based systems that are made by companies like Checkpoint and Juniper and Cisco. What do we use them for? Well, they can be leveraged for authenticating access points, edge or core devices like routers and switches and firewalls, VPN concentrators. You can authenticate users against a VPN via an ACS box. They can be set up for NAC. They can be set up for dial-up services, such as modems. Okay, they have a lot of different uses. ACS has been around for a good 15 years now, and it is one of the cornerstone tools that you should have on a network for security. Right? One of the key things that the I've been training the CCDC team for the national competition this weekend has been they're going to come into an environment where they're going to have a setup, and they have to put forth a proposal of how to improve that setup. They've got to basically do a network redesign. You know, it's going to be their homework for the first night. Okay, so we've been working on this pretty heavily the last week. So typically, let's just kind of quiz you guys on what you know right now. If I have an internet connection, I come into I'm not even going to give you that. I'm going to have you come into a hosted environment, a switch. Your internet service provider is providing your gateway. You have all your servers and workstations hanging off your switch, right? Your internet service provider does everything. It does your NAT, does your translation, everything, okay? Bear with me, don't look at me that way.
I'll unplug.
You get penalized if you unplug, because you're running an active environment. Check marks are nothing more than laptops or workstations. Right. Oh, and then out here in the cloud, you have 3 VMs. Just, you have no access to a terminal server at all. You have no access to like an ESX box. It's just get to these via RDP or SSH or Telnet, typically. That's it. So there's no way else to get to them. Pretty open, huh? Pretty scary, huh? The fun part about it is I've come across networks like that in the wild. So how do I get from here to something secure? If I were to redesign this network, what do you think would be the first thing you should do? That you would recommend to do? Yeah, I agree. That's a great first step. So let's work this from the top down. VMs. Let's put a firewall right here. Now what will a firewall do? What will a firewall do? What's the first thing it's going to do for me right here? If I maintain this, what do I got to do?
Allow traffic.
Well, no, not just that. Let's talk about it from the layer 2, layer 3 area. Right? If all my IPs are on here are public, right? I'm not doing any kind of network address translation at all. They're all public IPs. Yeah, I know. Again, I've come across it in the wild. What do I have to do here first? It's on your test. What do I got to do? Don't I need to re-IP these things to like a private address space? Take that out of the mix so they can't hit a public IP dead on. So if I did a scan of this network, I'm not only just going to pick up a web page here, I want to pick up whatever else is running service-wise. Alright, this is a Windows box, alright, and it's on the domain. I might pick up 3301, which is NetBIOS. Alright, if it's a Windows 2003 server, unpatched, running NetBIOS, over in here in lab 5. I can pop that box really fast. The MS08 vulnerability. SQL. Typically, these types of systems are linked in some fashion. They're talking to one another. Okay? Even though I put a firewall in place, say I NAT everything, put everything on the switch behind it. Make this my workstations. I put all my workstations behind it. What else do I need to build? Because I want to keep it separated. It's in your test. What's the type of network that I can build that is not, it's quasi-trusted? A DMZ. I put all my servers over here. So I have my, now, what's the one server I don't want to put over here? I want to keep it completely behind my firewall. Why? It's easy to compromise. So I'm going to keep my SQL server behind my firewall. That means my HTTPS server, it's got to still communicate, so I've got to build a hole in here so it can work with it, right? Everything else, FTP, SMTP, I'll probably put my POP3 server here. So that I don't need to have that open to the world, I just need to have an SMTP gateway. Alright, I have my web server, FTP server. Alright, good. Okay, now, from what you've learned, what other types of devices would be useful from a security standpoint that we've talked about in this class? Anything, name anything. We've talked about a lot of different devices, appliances. What would be good? We're just talking about one here in lecture tonight. What's a good one we can use?
RSA, software.
What does that go through though? What type of a server? Dude, it's staring right at you. ACS server. Right. I know it's late. Come on, bear with me. You want to put an ACS server on the inside of your firewall. Okay? Because it's going to be authenticating typically against some sort of LDAP or Active Directory database. And you don't want to have that communication a hole here for that database communication. You want to have it fully behind your firewall, so it does not have a public IP, it's not accessible. If you have anything that needs to authenticate against ACS, firewall, an outside router, what have you, it needs to go straight to this box on the inside. So that's good. What else?
Does that imply your LDAP server on the inside?
Yep, so here's my AD. You know, or I can have a Linux LDAP. Say I'm running a CentOS box. ACS is not limited to authenticating against one database. It can authenticate against as many databases as you want it to. We'll get to this in a little bit. It can have different groups, different privileges, different group policies. It's a pretty powerful little machine. What else can I put on the network that will help me from a security standpoint? What else would I want to put on it? Perhaps if I wanted to watch traffic, see if people are attacking me, what would I do? Packet analyzer is good, but there's a certain device, appliance that I can put on it has a packet analyzer inherent to it. Built in. An intrusion,
Yes.
an IDS or IPS, intrusion detection or intrusion prevention system. Now, here's the thing. If these are different switches, we're talking layer 2. If I put an IPS sensor on each, okay, and it reports back to typically a logging server like Splunk or Snort or both. Okay. The other thing I want to do is if I can make this a LAN, not a /30 but a /29. Okay. I can then home run it back to the inside. If this is a sniffing port, it has no IP, it has no way of being compromised, you cannot backdoor me. That's the key piece. Alright? So that's why I put a dotted line here, because it's not going to have any type of connection whatsoever. Yeah?
That would be untraceable?
Huh?
Is that untraceable?
That would be untraceable. It would be a stealth box. Okay? Now, here's the reason I have so many sensors in an intrusion detection system. If they're all reporting back to a Splunk and or Snort server, I can look at my traffic here. I can look at my traffic here. And I can look at my traffic here. What can I do at that point? Splunk does it for you automatically. And then you just have to write reports. I can correlate all that. So if I have a trigger that hits on the outside of my firewall and a trigger that hits on the inside of my firewall, I got a problem, don't I? Right? If I have a trigger that hits on the outside of my DMZ, I got a problem. I got a trigger that hits on my DMZ and my inside, I got a really big freaking problem. Right? That means something's gotten compromised somewhere. Oh, you know what I forgot to put in here? DNS server. No internets. Both internal and external. Alright. So that's a good thing to have. What else? What else will help me? With access. What will help me with access controls? ACS. Other than ACS. Okay. That's all great. All this stuff is great for defending from here down. I also want to have a NAC server of some sort. Network Access Control Server. What that's going to do is allow me to control devices coming onto my network, whether wired or wireless. Okay, and I can look at their posture. I can look at, okay, I have a laptop that's connecting. It might be, a visiting person, VIP, dignitary, what have you. But you know what? Just because you're that doesn't mean you can't follow my rules. Do you have an antivirus? Do you have an anti-malware software? Are your signatures patched? Is your operating system patched? I can ask all those questions. And you don't have to give it to me. You don't have to give me any answers. You also don't have to come onto my network. So you get to play Big Brother a little bit. Alright? Finally, extend this a little bit. The network management system. So I can monitor everything. Alright? Up, down, bandwidth, CPU, memory load. Okay? Do patch management through an NMS. I can collect log information. I can do all kinds of reports. Alright? So, really basic. After you get the problem, kind of complex, huh? Right? This is what you have to have in your heads when you leave this class. Because I guarantee all of you this. You will come across at some point in your career. People who are graduating from other CIS and CS programs at the community college level or these pay for your degree institutions. And yes, I'm going to pick on them like Westwood. Right? They don't care if they ever get past here. They don't care. Hell, half of the faculty can barely even teach this. Alright? When you go out into the real world, if you can talk, you don't have to necessarily do. If you can do some of this, that's great. That's wonderful. Alright? If you put the time in and learn a quarter of it, it's marketable. Alright? But if you can talk it and understand the concept and draw it out, you will land a job. Guaranteed. Alright, if you're so looking for one. Okay, I come across our graduates all the time, and I've only come across, well actually I can't say him, he was a CS major, not a CIS major, so he doesn't count. I come across our CIS grads all the time, and for the ones who've had me or gone through the IA program or the MSBA program, they're doing good things. They're doing wonderful things out in the industry, and they're making a lot of money. Okay? And you will go out there and you will do great things, and I hope you make a lot of money. I really, really, really do. Okay? But you've got to put the time in. You've got to have an understanding of why this is not good and that's good, and be able to articulate it and understand what each of these pieces does. Okay? Because you not only need to get to this level, you need to get your CFOs or your bosses or your owners to fork over the coin to put it in, which is sometimes the hardest part to do. Alright? Sometimes it's the hardest part to do. I forgot a device. Because there's EPS server. Endpoint security system. Stuff that's going to monitor all your antivirus, anti-malware, your updates, push your updates, like a Microsoft CIS server or Forefront server, although I don't recommend those products. Okay. I'm a big Trend Micro fan. Always have been.
You don't like the WSS server from
No.
Microsoft?
No. From where?
The one Microsoft has?
No. No, you can ask my interns. Every day I go in there and I want to pull it out of the rack and just put a thermite grenade on it. Call it a day.
So what do you use in its place?
A Trend Micro server.
Your company just put one in not too long ago. It took them 4 months to set it up.
Yeah, it's ridiculously retarded in having to set it up. And then if you don't tweak it right, it will suck up all of your bandwidth when it does updates every third Tuesday of the month. Yeah. Yeah, when they go through research and development at Microsoft to test these things, hey, it works great. Yeah, dude, you're sitting on 100 gig freaking pipe. Of course it works great. Oh, I'm sorry. All your updates are local to Microsoft. What was I thinking? You're not pulling anything over the internet. Geek. All right, protocol database compatibility. Look at table 91292. It'll go over the different protocols that are capable on the ACS box. Some advanced features. Share profiles. So you can share profiles across like an Active Directory. You can do dynamic ACLs and download them to a router or firewall. Network access filters on individual devices. Radius authorization component. So that's part of the second A in AAA. You can build shell command authorization sets. So if you remember how you made username, password, privilege level, there's only 2 privilege levels that you can use, 1 and 15. So what's up with 2 through 14? 2 through 14 are completely customizable if you do them with an ACS server. So you can tell what users and what groups can use what privilege level and what commands they can execute. Very, very, very robust. Pain in the butt to configure. A lot has to go into it. A lot of planning. Network access restrictions, so you can restrict users. Machine access restrictions. This is based on IP. This is based on individual IP or our host. And network access profiles, based on either groups or individual users. We go over the configuration of ACS in page 297 and 307. Let's talk about multi-factor authentication a little bit. Okay, AAA. Give me a second. Sorry, I get cyber distracted. Techno stress is what they call it. Quick review. AAA stands for what? Authentication, authorization, and accounting. All right. Or the who are you, what do you know, and what do you have. All right, identification and authentication are kind of the same thing. So that's single factor. Do I have a password? Single factor. All right. With AAA, our username and password pair, I get two factor. I have to have a username and a password. With multi-factor authentication, I have to have at least one additional step. Whether it's a code that gets pushed to my cell phone, from like a mobile pass application, an RSA key, okay, that cycles through based on time. I have to have some other piece of information in order to give the credential set in order to log onto a device. That's all what multi-factor authentication is. Now I can take that past that, okay? A good example is when I worked at one company, we had a server that integrated with our AD and pulled off our cell phone information that had to be integrated in AD. So when I would log into a certain system or certain systems, I'd have to give it my username, my password, my RSA key token, and it would call the system would call my cell phone with a fourth token that I'd have to put into the system.
Within 60 seconds?
Within 60 seconds. You had to time everything right, man. You know, and it's one of those things where, look, I had a case where I had an engineer who was telling me that a customer had too much security. All right? Yeah. He's telling a guy, and this is a security engineer. He's telling a guy who's running a services department, who teaches at a major university, who teaches network security at a major university, who's the coach of a cyber defense team, that there's too much security.
No such thing.
No, exactly. I go, dude, there's no such thing. You're just being lazy. I said that straight to his face. You're just being lazy. So I went in and he's like, I can't get into this VPN. I can't get into this VPN. I go, well, did you try this? Yeah, I tried this. Okay, well, did you try this? What he was is he had a mobile pass account that the customer had set up for him, and he'd VPN in with the one set of credentials, right? Then he'd have to SSH into a device, an ASA or a router. Well, by the time you get there, you're past the 35 seconds that the mobile pass is good for, so you've got to redo your cipher. You have to re-get another access code. He was not doing that. He was using the same one. I'm like, did you read the instructions? Okay? He's a nice guy, don't get me wrong. He's a good guy, but again, difference between college graduate and somebody who went through another program. Two-factor. One-time passwords, STs, which are outdated. OTPs, these one-time passwords are going to counter replay attacks. Okay? So because I have that access code, that additional factor or factors of authentication, if I'm able to capture that packet stream, yeah, I got your credentials, I can't reuse them because I cannot replay those packets back at the target because that code is not going to be good. I can't kick you out. Okay? So this is the big deal about using multi-factor authentication. Okay? Is countering replay attacks. Like Steve said, there's no such thing as too much security. I fight this with engineers all the time because, again, it comes down to one thing: they're lazy. We engineers, we're inherently lazy. Period. Okay, configuring ACS on Radius is covered in page 317 through 321. You can also look at RSA configuration, but we do not have RSA tokens for this class, therefore we can't do it. Do I have any questions about lecture tonight? Or the test? Or the lab? It's an interesting camera, that's no camera. Or is that for the iPhone?
For the iPhone.
Nice. That's kind of cool. All right, guys. Have a good week, and we'll see you next Tuesday. There's nothing else. I'm going home.